This follows on from some of the discussion we're having before, and this is looking at some practical ways in which African countries could align their datums with the ITRF without having access to a regional reference frame. These are some information that I gathered from Zahir El-Tamimi, and I put it to him. I said, Zahir, you help build ITRF. He knows a lot more about reference frame development than I do. But I put to him this scenario is if you want to be able to have a modern reference frame in your country, can you do it without a regional reference frame? My assumption was yes, and he said, yes, of course you can. And he gave me some guidance material that we could use in this presentation. So you'll see the slide deck has a few more slides in there that go through things in a bit more detail. I just want to try and cover the concept here so that you can understand the main point I'm trying to make. And then you can go back and review some of the details later on if you'd like to. If you look on the screen, you can see the red points here. The red points are the ITRF or IGS sites. So these are the high accuracy GNSS sites that are used in the determination of the ITRF. The blue sites are sites from within Africa. And what Zahir was doing with this scenario was he was analyzing all of the sites that he had access to in Africa at this time. I don't have the date for when this happened, but it's just used to show how you process the blue sites in combination with the red ones. And by holding, you think about it like points in space, you're almost holding the red ones fixed and you let the blue ones float a little bit. And then based on the measurements that you have baselines between the blue sites and the red sites, if the blue ones can float around a little bit, they will fix themselves to the best position in alignment with the red ones. So the red one is giving you the control. And the blue ones therefore fit in amongst the red ones as best they can and align themselves with the ITRF or the IGS. That's the concept of how you can do this and link yourself with an international frame. So here were the sites that Zahir provided me with. As I said, I'm not sure when he did this analysis, but as we've seen from some of the other information presented today, a lot of these data sets are not very different. There are some small differences, but it shows that there's still a lot more data that needs to be captured and shared in order to improve this at a regional scale. So what we're talking about here is this alignment between the national and the global if we're skipping the regional reference frame. So here's an example where we asked Fernand to provide some data to us. This is a very small example, and it's a very simple example just to show you the concepts and help you understand it. So Fernand shared with us a range of data, GNSS cause data from Côte d'Ivoire. And the information, we wanted to align that with the International Terrestrial Reference Frame, the most recent realization of ITRF. So what we did is we linked that data from Fernand in his country using IGS products. And some of this will be new to you. You don't need to understand the details because you do need to be an analyst to do this information, to do this analysis. But what I'm trying to show you is what we were doing is we were linking to those red sites that I showed you before that are continuously operating. Now, AusPOS that I mentioned there is the computational software we use to run this analysis. And this is the Australian online positioning service that's run by Geoscience Australia. And what it does, it can take in your data and it will process the data from your country, in this case, Côte d'Ivoire, in relation to the nearest 15 red sites, the IGS sites from around the world, to create that connection between your datum and the International Terrestrial Reference Frame. And then it provides you outputs in terms of coordinates and velocities and uncertainties with respect to ITRF 2020. So how does that happen? Here's a link you can go to where we have the Australian online GPS positioning service. And this is not the only one available. There are many others out there. Canada has one and the US has one in particular. They're the two I'm most familiar with apart from the Australian one. And they offer very similar services. So you can use whichever one you like. I've just used this one because it's the one I'm most familiar with. You provide the data in static mode. So it's not movement data. You're either providing information that's come from a cause station, continuously operating reference station, or from campaign observations where you might have 7 days worth of data. It needs to be dual frequency data, so L1, L2 or L1, L5, and it's the GPS carrier phase information that's provided along with the code data. So this is the high precision signals that we get from GNSS satellites. It's often provided at 30-second intervals, but you can provide anything and it aggregates it down. We recommend that you provide at least 2 hours worth of data, up to 7 days worth of data, and you can provide it in Rhinex versions 2, 3, or 4. You then put in your information about the site. So you put in information about the file name, the antenna height, the antenna type, and then you upload your observation files. I'll skip over that bit. Again, these are details. I will draw your attention to the part at the bottom though, where you can submit your data. If you submit it about 2 or 3 weeks after you observe it, it's using the best quality orbit products. So the orbits of the GPS satellites that we have, they can be ultra rapid, or final. And the longer you wait, the more accurate the definition of the satellite orbit is that we have for that site. So what this means is after about 2 or 3 weeks afterwards, we have a better understanding of where each GPS satellite was at the time that you took your observation. So if you wait 3 weeks, you'll get a better result of your coordinates on the ground, is what it's spelling out. So what we did here is we uploaded the data, you submit all your files. Here's just the metadata that you can go back and have a look at. We also are trying to do the study also for some South African stations. We haven't been able to finalize that yet. We're still working with Aslam on that data. So what we're looking at here are the results from the information on the right-hand side from the 3 stations in Côte d'Ivoire. And this is the IGS. This is the equivalent of what the red dot network was before. So when we ran these solutions, we're using the most up-to-date IGS information. And if we jump through to this one, you can see where the 3 stations in yellow that Fernand provided us with, and the reference sites in red that are highlighted around that region that were used as part of the analysis. So the box up the top is giving you the 4 character IDs for the stations in Côte d'Ivoire. And in red on the right are the 15 nearest stations which we use as reference stations for the analysis. And then you can see we're using the final orbit products, which means it was more than 2 weeks after the data was collected. So it's going to give us the best result. And here's the coordinates that come out of it with respect to ITRF 2020. So Fernand could have provided us this data. It was just normal GNSS data that came out of the receiver. We have then analyzed that with respect to other ITRF coordinates. And then out of that, you get Earth-centered Cartesian, that's XYZ, so center of the Earth reference frame coming out from the Z at the top and then the X and Y axes. You can then easily convert those into ellipsoidal height and latitude and longitude. But it's best to give the coordinates out in XYZ because it's the most precise. And you can see we've got XYZ coordinates in ITRF for each of those 3 sites. Now, as you can imagine, if we had have done this for 40, 50 sites around Côte d'Ivoire, that gives you a ground network of coordinates, and they might be passive marks. They could be survey marks in the ground that you've observed for 3, 4 days, maybe a week's worth of data. You can submit those 30 to 40 sites. It'll analyze that data with respect to other ITRF sites in the region, and you'll end up with coordinates. Have we got an estimate of uncertainties here? There you go. There's the positional uncertainty for them. You're looking at the sub-centimeter level with latitude and longitude and just over a centimeter in height. That's not bad for a national network that you're trying to establish ground control for. You could have a ground control network with latitude, longitude, height at the sub-centimeter level And then that's your ground network that's linked with ITRF. Then from that, as we'll talk about tomorrow, how could you then fill that in with all your other terrestrial data you've collected across your country, whether it's total station data or whether it's old trigonometric data that you might have, old bearings and distances. You might have leveling data. You'll have other GNSS baselines that might be a lot shorter time frame. You link all that data and you fix it to these sites that we've just computed with respect to ITRF. So in this scenario, we used Fernand stations and we let them float with respect to ITRF or the IGS. It's the same thing. We're using IGS to define how we're going to fix these ITRF sites. So we've allowed your ground control stations to float. We've fixed that to ITRF, and then we have a good fit here with positional uncertainty. You then can put this in an adjustment and you hold those stations fixed or with these very small uncertainties, and you fit all your other data to it. As soon as you've done that, you've got a new national datum that's linked with ITRF. So computationally, it's relatively simple once you've got all your data sets set up and you know the uncertainty of your data sets. And this is showing how you can use open software that's readily available for you to do this kind of technique. And we'll step through this with the next step tomorrow to show how you then add your localized data and fix it to this data set and what software you can use to do that. And again, there's software that is openly available for you to do this kind of stuff. So when I talk about being able to do this, start now, this is how you can start now. Collect the data, run it through an online positioning software, then run a national adjustment of all your localized data sets, and you can have a new geodetic datum that's linked with ITRF. From a technical perspective, it is that simple, and there are people who can help you with it. Which bit, sorry?
The acoustic statements.
Yeah. Sorry, Ryan's just pointed out the accuracy statement at the bottom, that should be millimeters, not centimeters. You're getting 4 to 6 mil, and in the vertical, you're getting 10 to 12 millimeters, which is very, very good for this data set. So yeah, good data, Fen. Good data. And he didn't know, he hasn't seen the results yet. So he was getting a bit worried. And underneath this, I've captured some further information that goes through the processing details and more information, the model types and things like that that are used that you're welcome to go through. Now, the last thing I wanted to touch on was this scenario. So there is an example here that you could maybe also learn from how the Asia Pacific do this. So we saw the Asia Pacific reference frame before, and I showed you how that data gets analyzed every week. But there's still a number of countries in the Asia Pacific region that don't have continuously operating reference stations. They only have ground control marks, and they can only observe those with GPS equipment maybe once a year. So in those scenarios, they run a campaign, and at about the same time every year, they encourage countries to go out and collect information, and then they send that data to a central repository, which is within Geoscience Australia, and all those campaign observations get computed and analysed all within the same time frame. So the reason for doing it at the same time is seasonally, we can take out some of the seasonal signals that you might get in different parts, particularly in Asia region, where you get a lot of hydrological modelling issues because of the, if you look at the India, Bangladesh, you can get severe flooding in certain times of the year. So they've tried to prioritize it around the same time of year. Long story short, that means you can capture a lot of information in the similar reference frame. So this is another example of what Africa could do, even if you don't have cause observations, if you don't have them continuously operating, you could still run a campaign in much the similar way that the Asia Pacific team do. So I've included a bit of information about that here. I'm not going to read over it again, but it's in there for your reference. This is a way of, again, capturing more information, but not letting perfect get in the way of the good. This is something you could start now to say, we're going to run a regional campaign once a year in Africa, and And we're going to collect a whole range of data and have someone analyze it. And it's going to give you a much stronger control network throughout Africa rather than just relying on cause data, which may take a number of years for you to get to that point. This has been running very successfully in the Asia Pacific region for over 20 years now. So there's a link there with some more information, how to use AusPOS, how to submit the data, and you'll also find some information about running these regional campaigns. I think that might give you some options for how you move from where you currently are, maybe through doing regional campaigns, strengthening your cause observations, all on the path to developing a stronger ITRF network as you work better together. So I'll stop there. I'm happy to take any comments or questions. We've got about 20 minutes left for the day. Yes, thanks, Bruno.
Thank you, Nick, for the presentation. Please accept my question. I'm just curious because from the Côte d'Ivoire example, I just want to know, was there a pre-processing activity that was done just to look at the issue of the solar cycle that we are in the event that we are towards the solar max? So it means that the ionosphere, regardless of where we are, it has an issue. So did you do some bit of cycle slip detection and repair, or we just got the data as provided, then we did a processing? So kindly guide us on that. Thank you.
Yeah, there's a pre-processing step, and I've got some of that information stored in this presentation as well, if you want to look through the details. There is some free and openly available like QA, QC, quality assessment, quality checking software that you can use. The simplest way to do it, though, is to take the data straight out of the receiver and try and put it in AusPOS and see if you get a result. Because AusPOS will tell you some of these quality metrics. It'll give you in the report, it tells you how good the data set is, whether or not there's any data issues, and there needs to be something seriously wrong with the data to not get an output. So I would just put it in first and see if it can do the quality checking for you, because you'll get a coordinate assessment at the end, as well as an indication of the cycle slips and things like that. So in this case, we didn't need to do any other pre-processing because the result came out fine, but there are some other software techniques that you can use to be checking your data before you submit it. We'll go 1 and then 2 and then 3.
Thank you, Nick. Excuse me, I will speak French. Voilà, donc,
there we go. Thank you so much, Nick, for your presentation. Well, yes, I could confirm that this is an outstanding opportunity. This is a tool that I got the chance to use following an observation campaign in 2019 in Senegal. And the data, when we processed it, showed us that we had the same type of scale. So it's something that we did with a number of organizations. And there was concordance between the two tests. Now, when we look at this current version, I believe it corresponds to the one that I used back then. So we take into account the IGS stations. Do we take only the closest ones into account, or there's a geometry of the closest ones around the network? Can they be integrated into the network as it stands today? And lastly, and this is perhaps to the colleagues, so this gives access to everyone to enjoy very precise results, but we have to be very careful when it comes to the geodesic bands as part of the observation campaigns. We have to make sure that the height of the antennas is the right one, which is possibly the only source of errors when it comes to processing the data. Otherwise, it's just a question of gathering the data, analyzing it in an appropriate way, and generate the right results. Thank you.
Yes, thank you for making the point. It's if you put rubbish in, you get rubbish out. Yeah, if you put in something it can be very precise, but you may end up with something very inaccurate if you put in the wrong antenna height. So you need to make sure that you understand where the phase center is and what kind of information you're putting in. So good point. On your other question, my understanding is it's the nearest 15 IGS core sites that go into the submission. Thank you.
Okay. Thank you for the presentation. However, my is just kind of a suggestion or recommendation to the committee to. This is the aspect that usually people are kind of left behind. They, most of us, maybe surveyors that are not usually into geodesy that much, might not understand the rudiments involved in all kind of these things. So I'm just kind of suggesting to the organizers, if you can throw more light or kind of make further programs for people to kind of be familiar with what software or how to detect, how to tell when you have issues. Because like you said, garbage in, garbage out. One might not know he has inserted or part in the wrong data. So that's my comment. Thank you.
Thank you. I think that's an excellent suggestion. When Ryan and I and Eva were originally designing this workshop, one of the things that I was really keen to do was to work through a very detailed example of how you could do something like this. And we quickly realized it would take 3 days. And it meant we would have to cut a lot of information. So instead, we still plan to do something like this, but we will either do it next year in a separate, more detailed workshop. And I think something like this kind of concept of running through with real data to do a proper assessment of the of that link with ITRF first, and then the link with the national datum that we'll cover tomorrow. We would either run it in more detail and just run a global one and invite people from around the world to come, or we will run a series of webinars where we're going to record these and do it in detail so people can watch the videos. One way or another, I think it's a wonderful idea, and we definitely will follow up on that, because I think there's a lot of details in each step, and we would be doing it an injustice to try and cover it in 1 hour or something here. You can't do it. And to look through real data, find real problems, remove those real problems, check the data again. I think that's the reality of how you can learn to do this. So yeah, our year of capacity development this year is trying to cover a whole range of things in a small amount of detail and get everyone up to a certain amount of speed. But we also want to collect this information from people like you to say, what would you love to do in more detail? Because that's the sort of thing that we'll look to do next year. So thank you for that feedback. I appreciate it. Edna, thank you.
Thank you. My question is on OSPOS and Banese software. I'm wondering, are they giving the same accuracy? Why is it that some are opting for OSPOS and then Banese? Yeah. Okay.
It's a good question. OSPOS actually uses Bernice at the moment. So OSPOS is like a package that's in between the very complex way to run Bernice software. I've run Bernice before. For any of you who have, it's really, really hard. It's really hard to learn. And then there's CatRef, which is the combination software that Zahir uses. Zahir tried to run a workshop with that. After a week, I still didn't know how to run CatRef. So there's some software that is really, really hard to learn how to use. So what OSPOS does is it creates modules or functions that sit on top of it and sort of wrap around Bernice. And you give the information into OSPOS, and then OSPOS gives the information to Bernice, and then it comes back through the OSPOS interface. So OSPOS is almost an interface between you and Bernice to try and make it easier. So it can't do everything that Bernice can do, but it can do the things that you need to do the most. And that's where OSPOS helps. Easy.
Just to buttress what some of us have said concerning garbage in, garbage out. So I'm just thinking aloud, can there be, just like OSPOS, which is used for processing, can there be like a software that will use for checking the accuracy of the data first? You know, you check it, if it passes that stage, then you know that it's good for you to insert into the OSPOS.
Yeah, there are some free software available to do that. Things like Tech or RTK Lib. There's a range of different software packages that enable that already. So we can give you some links on those as well. We can share those so that, and I think there's some good user guides as well. I think Tech in particular was done through UNAVCO, I think, years ago, and it's quite mature. So that's a good one to use. Yeah. One and then two. Can you keep an eye on that side? Sorry.
Alors, bon, je vais parler.
So I'm going to speak French. My question is, now I've already used OSPOS for data coming from a very restricted area, small area, but now at a national level, covering the whole of Senegal, we have over 160 points, and we have a number of stations that record raw data. Can we use OSPOS to calculate all of this data? Now, the outcome, is it limited, or can we use all of the data to come up with a solid calculation?
Yeah. Thank you for asking that question, because it will stop me getting a lot of angry emails from people in Geoscience Australia. It does have limitations. I can't remember exactly what they are. The reason I use OSPOS to describe this scenario is to show you how you could do it for a smaller set of data. Having said that, there are systems in the back end of OSPOS that we use it for the Australian datum. So those systems and processes and software are available and would be open source. They would be a little more complicated to use than the simple interface with OSPOS. They would be more script-based, code-based back-end things you could type in, but there's a clear procedure on how you do it. So this would be something we would like to include in sort of a workshop where we talk about that in more detail next year, to show if you had 20 sites, you could probably use OSPOS. If you're looking to put in hundreds or thousands, like we've done in some of our other tests, you would use a batch processing method, which is more done in the back end. It's only slightly more complicated, but it's not something that I took you through here, and it would require a little bit of extra training. But again, we could make that sort of software available.
Right. Okay.
Yeah.
Thank you very much.
We'll just go here first, and then I'll come back this way. Yep. Okay, and then one here. All right.
Okay, thank you.
You as well? Okay, sorry.
Okay, thank you. I think I didn't introduce myself because I'm being late, so I will introduce first myself. I am Kandu from Ethiopia, Badr University. So my question actually is to show my concern. Ethiopia is located in a Rift Valley system, and then there is architectural activity there. So as AFRIF or as UN-GGCE, is there any initiatives to establish more core station there to monitorize the geodynamics in the area? So is there any activities or initiatives to establish more core station in the area as an AFRIF or UN-GGCE? The other question is, most core stations have been established by the universities concerned. Myself, Badr University has one core station, that an core station established by Institute of Land Acquisition. So now it's not working because of power, because of internet connectivity. So is there any plan to reestablish or to rehabilitate or to upgrade them by these initiatives? Okay. These are my concern to ask you. Thank you.
Do you want the short answer or the long answer? The short answer is no. I'm sorry, but from a UN-GGCE perspective, if I take you back to something I mentioned this morning, our role is about building political support for geodesy. It's not about putting new infrastructure into the field. If that's important to you, my role would be, how could I best support you and your country to do that? But I can't do it for you because the problems are too big. So we don't get involved in actually the control of infrastructure. Now I'm going to go right, Fernand, and then Joseph, and then Alette. Yeah, we've got a few to get through, and we've only got 10 minutes because we need to let our translators go. So can I please ask that everyone keeps their comments or questions very short? Thank you.
Sorry, mine is just to add a little voice to what Nick was saying, but in a little bit another dimension to add, that I think it will also be good for us to not to limit ourselves on online processing. It's also equally good for us as geodesists to know how to do the processing ourselves right from the word go. Because I'm saying so because some people will just rely on the software. You don't know what is happening behind the scene. Whatever result you get, you just accept it. And you said that is the final result. So I think it is equally good, in as much as you also do the online processing, you should also know how to collect the data and also do the reprocessing yourself. It helps a lot. And then a rider to the answer that Nick gave in respect to ionosphere, that is in addition to what Nick said, that we do pre-processing to be able to look at the accuracy of the data, the reliability rather of the data. It is also, when you are doing processing within the software, there are algorithms that have already been built in that enables to handle the effect of the ionosphere. So aside from the area of the pre-processing, then when you are doing the processing, the ionospheric content is as well being addressed, because there are some algorithm models that have been built in to knock off the effect of the ionosphere to enable you get a precise positioning. Thank you.
Thank you very much. Oui, en français, ce sera mieux.
It'll be easier in French. Well, just to come back to the discussions on OSPOS, it's an outstanding example that was shared with us. And I'll seize this opportunity to turn to Senegal and other countries. Aslam presented this early. There's the Geodesy working group that was set up at a continental level with different stakeholders. This is a space where this type of a problem can be tackled, or at least it can be addressed in a more collegial, more holistic way. So we enjoyed an opportunity to engage in discussions with Ryan. Ryan is available to assist us. Now, it would be interesting to do this in a coordinated way, rather than send individual emails, which would simply max out the mailboxes of experts who have so much other work to do.
Good point. Well made. Thank you. Now, where were we over here? Ryan, I'm going to go to you. Sorry. Yep. So very brief, please. Very brief.
Yes, okay. Thank you. Alors, merci beaucoup. Donc,
Thank you. Thank you so much. So for me, this is an example at the level of the OCS where there is integration between the observations on the ground and observations made at the level of permanent stations. I'd like to know in these networks, what is the minimum limit and the maximum limit defined for the geodesic baseline? What type of models can be used to manage meteorological modeling?
So as I said, some of the details are in the slides. So I would recommend going through the slides that I didn't have time to cover today. And if the answers aren't in there, please let me know and I can send you more detailed information.
Merci.
Yes, thank you so much. I just wanted to ask a question regarding the plan to make this investment sustainable. This is very important. So within the framework of the modernization of geodesy in Senegal, our idea was that when we bid, we would develop the network with open source applications, fully open source. But then, of course, as we went into it, we weren't so sure. So my question is, can we really incorporate the station network with the physical network using purely open source? Now, we had problems, we had private stations, initiatives that were present. But after this project, we noticed that some of these installations don't work because it was too difficult. We required licenses and so forth, and we attempted to do this within the framework of our technical specifications, but we came up with problems and we had to move back to proprietary software.
It's a good question, and it's a common question. Can you run a network with open source? Yes, you can, but you also need the capacity. You need the people who understand how this open source software operates and to maintain that software and to sustain that software. So this is where it often will fall back to the use of proprietary software, is if a country doesn't have the people able to run the software and maintain the network. So I always look to try and find a good solution. I think there are strong connections between public and private. Where the control sits, I do recommend that countries look to maintain control of their infrastructure and potentially then look to license that information out, which then can be on-sold to customers. So find the area where you're comfortable performing a role and where you think industry can better perform a role. But if it's on the back end, it is very difficult to run open source software and maintain it unless you have the staff who understand how that software works. Now, Alette, I was over to you next, I think, and then was it Zuhair? Yep.
I cannot find the information right now. Maybe I'll add a slide to Wednesday, but just to answer your question, there is some solutions. The Geodesy group in South Africa, for example, has worked on, and I think Aslam knows about this as well, kind of container with GNSS receivers, weather stations, everything that can easily be installed. It can be in some remote area. It works with solar panels, connectivity, all of that sorted out. I'll give some more information maybe on Wednesday. So there are solutions. Yes.
Thanks, Alette. Zuhair?
Okay, just Nick, for the quality checking tools available, I want to say that TechC is no longer supported. So there is another alternative, which is GFZ RNX. Okay, but it is still available, TechC. We can use it with all their data and okay.
Thank you. Thank you. We've got time for one more if there is. You just want to wave? Hello.
Okay.
All right.
You allow me for 1 second?
Please,
yeah. Okay. I'm happy that you introduced the outposts and we have others into the Geodesy community. But in Tanzania, we actually don't support that much outposts because it's making Geodesy lazy. Because they don't like to learn a little bit what is behind the software. And another thing is that we don't have a control of what are the IGS or ITRF IGS controls that we can use. We let the black box to tell us where they can anchor the solution. And well, you get the solution, but anyway, you get the solution, but it's not tangible things that if you wanted to build capacity, we need to go to maybe to that direction. Thank you.
Thank you. If you love that talk about AusPos, you're going to really enjoy the AI presentation that I give you tomorrow. So wait for that. That's real black box stuff. All right, I just want to pass over to Ryan for some final comments. Thank you.
Thanks. I think this session has been really interesting because it's generated more than 20 interventions, if we call it in the UN term, which has been really good. So it obviously makes us aware and confirms to us that this is a really important technical task and activity that we'll work on. So thank you for your feedback around those. And we'll also think about different mediums about how this can be shared. I do just want to add one technical aspect is that OzPOS is able to work globally. It's not geofenced, whereas some of the other online tools, NRS CAN and Opus from USA, they are geofenced. So if you put in a data file from South Africa into Opus, I don't think it's going to work. I think there's a geofencing on there. So that's just one thing to be aware of. And I really appreciated the discussion where there was talk there about the capacity that OzPOS and similar tools could make geodesists lazy. Absolutely agree on that. I wish I had this when I was doing my undergrad to be able to check things. But we have to also temper it with the fit for purpose. And the other topics we're going to talk about is availability of geodesists. We have limited geodesy people. We all have too many tasks and not enough time or not enough hands. So we also have to be aware about being fit for purpose, what tools can be used efficiently and smartly to help us progress. So while these are tools, they are tools. They can still be used badly. They can still have garbage, but it's another tool that's what the professional geodesists can detect if it's used well or not. So that's a closing point.
Thank you. Thanks, Ryan. And thanks to you all. It's only day one. We've only had one day. It feels like we've had a week already, doesn't it? Who's tired? Who's tired? Yeah? Just me. I'm the only one who's tired. All right. I'm going to sleep well tonight. Thank you. Yes. Thank you for your today. Thanks for your contributions and your energy. It's great. It's what I was hoping this would be like. And I'm looking forward to tomorrow where we'll start again. So please aim to be starting to come through security about 8:30. I'd like to start on time at 9 o'clock if we can. Last of all, thank you to Ryan and to Walla for your kind assistance today. Please join me in thanking them and our wonderful interpreters behind us. All right, we'll see you all tomorrow.
I guess. But tomorrow.